Okay, I think we're ready to start. Hello, my name is Olive Power. I currently work at VMware. So happy to be here in Sydney. It's only my second time here. I'm from Ireland originally, so I feel a little bit far from home. But it's a beautiful city, and everybody's made me feel very welcome. So thanks very much for that. Okay, just a little quick introduction about me before we go into the talk itself. I came to VMware with the Heptio acquisition. Heptio was founded by two of the original founders of Kubernetes, so we were a very open source driven Kubernetes type company that VMware acquired for its sort of strategic focus and concentration into the Kubernetes world. So I've been with VMware for about 5 months, and as I say, before that with Heptio. Before Heptio, I was at Red Hat, sort of working on their Kubernetes offerings as well, mainly in those sectors. And I just wanted to point out that I'm currently an instructor for the Cube Academy. And just in case you didn't know, we're running some of those sessions tomorrow. So it's like free, sort of, not free, but sort of, sorry, training in Kubernetes. We're going to be doing some introductory modules there. So if you want to check it out, there's one in the morning, one in the afternoon. So if you've got some free time tomorrow, come down. And I'm also part of the crew that we've sort of launched a new podcast within VMware as well. Not necessarily a VMware branded thing, just a few of us coming together. We have guests on it to talk about all things cloud native. So check those links out. There's a lot of useful information in there. Okay, so the agenda today, we're going to talk about operators. So this is like a really introduction session to operators, to maybe just to give you an understanding if you've maybe heard the phrase before, and you're wondering kind of what exactly operators are, and why should I need them, or why should your company be thinking about implementing operators. And then if you are thinking about doing that, then how would you go about starting on your journey of building your operators? And then after this session, I'd like to give you some sort of resources that I find really useful in a kind of a what next section, so things that you can look up and read about in your own time. So I hope it's going to be a useful session. But just a little bit of background first, because I'm going to kind of talk about these objects. So obviously Kubernetes is a platform for managing containerized applications, so we should kind of maybe all know that by now. And all the information about the platform is stored in a key store database called etcd. So all the information in and around Kubernetes is stored in this database, and any changes you make to Kubernetes will be stored in that database, and any information you want to retrieve about your system will be retrieved from that database. And the data is retrieved from that database through Kubernetes API server. So all interaction with Kubernetes is through API. So it's API-driven model, and it's always API first. And there's various ways that you can interact with the API, but most people are familiar with using the command line interface. And that command line interface we all know and love as kubectl. So with kubectl, you can run various commands that are retrieving information from Kubernetes, or indeed adding information to Kubernetes by creating things. So you can get pod information, or you can create deployments, or you can indeed delete stuff. And all that interaction is through the API, and ultimately that information exists in etcd. And the reason why I kind of keep talking about information in etcd all the time is because Kubernetes uses that information to drive the way it works. And the main driver for Kubernetes and how it works is to maintain desired state. So it's always striving to maintain the system as you have declared it. So it's a declarative system, always maintaining desired state. Now, if I talk about desired state in the human body, so I'm kind of an ex-scientist kind of thing, so I'll just refer back to my background just for a little bit. Desired state, is a concept that is not unique to Kubernetes or indeed any other sort of architectural systems like that. It's quite a common philosophy or a common way of working. And if we look at the human body, for example, in like a really, really, really oversimplistic view of this, so if the body gets cold, if the outside temperatures are cold and they're acting on the body, then the brain recognizes that the body temperature is dropping away from what its desired state should be. And so it implements some action to try and remediate that. So it implements, in this case, lots of different things, but I've just shown heat-producing mechanisms like shivering. So from a kinetic energy point of view, that will generate heat in the body, and it will start to raise the body temperature back up. So there's this kind of like analyzing the state of the world, taking remediating action when it's not as required, and then checking it again. And it's continuously doing that. And so if we look at Kubernetes in kind of the same thing, Kubernetes does and operates in that same sort of model, where you declare to the system what you want. So in this case, I've just put up a simple application. You want your application A, your pod, to run X number of times. That's what you've told the system you want to achieve. And the system will keep checking that to make sure that it stays that way, and it will fix it if not. So all the time trying to zone in to desired state. And we can represent that in a kind of like a simplistic, again, simple diagrams, I apologize. Simple kind of loop, what we call a reconciliation loop, where you tell Kubernetes what you want the system to look like, or your desired state. The system will check it periodically to make sure that that state is maintained, and it will fix it if it's not. And all the fixes will be implemented through interaction with the API to make sure that the system is as per desired. So as I say, we call this a reconciliation loop. And the elements within Kubernetes that implement this loop and do most of that work associated with that remediation is implemented through controllers. So I put it sort of my own definition up there. It's a software loop that monitors resources of interest. So in our previous example, it was our number of pods. We wanted it to run X number of pods. That's our resource of interest. So there'll be a specific controller that will maintain my number of pods, in this case, replica set controller, that will monitor my resource of interest, my pods, and compare the desired state to the actual state and take remediating action. So out of the box, Kubernetes has a lot of resources of interest. I keep talking about pods, but there's a whole load of other resources in there that come out of the box. And so there'll be relevant controllers for those, making sure that how you've declared your nodes, for example, or how you declared your deployments, there will be controllers to make sure that they're maintained as per your definition or as per your desired state. So there's lots of out-of-the-box resources, but of course, Kubernetes is extensible. You can add your own resources that you want control, because there is never any product, Kubernetes included, that does every single thing you needed to do out of the box. You always needed to do something else for your own specific use case, your own particular application, or indeed just some extra automation that you want implemented. You can now extend Kubernetes to get it to run that automation for you in this sort of declarative desired state reconciliation loop format. And so this is kind of, these new resources that you're going to bring to the system, they're kind of officially known as custom resources. And any attributes or definitions that describe those resources are called CRDs, or custom resource definition. And so I can have whatever I want Kubernetes to understand. So if I add a new resource called Olive, and there's some various attributes associated with Olive, like color or location, I can extend Kubernetes to understand those objects and those resources and those attributes, and I can declare what they should look like and write some logic for Kubernetes to understand, and it can make sure that Olive is in a desired state. And so because you've extended the API, you can now query those objects just like you can do out-of-the-box objects. So I can go kubectl get Olive /color, and it should bring back what the desired state should be for that color. So it's just a kind of a simple example, or a simple example just to show that the attributes and the resources that you can bring to Kubernetes can be anything. And you, as the operator or the person who wants to implement this new automation, will understand what those objects are, and you will define them to Kubernetes. So that kind of brings us on to the what part of the agenda. So operators are actually a class of controller. And they're the ones that implement and manage custom resources. So you have out-of-the-box controllers to manage your out-of-the-box resources. Operators are what manages your custom resources. So it's a controller still doing the reconciliation loop, But because it's kind of external to the system, then a new name was given to it, and it's called operators. So just remember, operators are a controller that are managing your custom resources. Okay. So, yeah, sorry, there's another point there that I missed. So they're the class of controller that are implementing your custom resources, and it's kind of like you're kind of coding and packaging software or code for Kubernetes. And what do I mean by that? So we've talked about the reconciliation loop and that there's some logic has to be implemented for you to tell Kubernetes, okay, watch this resource. It's a new custom resource I've just told you about, and I've added you to the API, so now you're aware of it. But you need to tell Kubernetes various attributes, CRDs, custom resource definitions, so that Kubernetes understands if something changes to those attributes, or Kubernetes understands which attributes it needs to watch and understand if there's changes to those attributes, what does it need to do? And the what does it need to do bit is code. You know, you can't get away from like implementing your automation as code. So you have to tell Kubernetes, okay, so this attribute has changed. Maybe the color, olive.color has changed from red to blue. What do you want me to do about that? What do you want me to do when that situation happens? In the case of the out-of-the-box stuff with pods, you know, if it goes from 5 to 4 and my desired state is 5, Kubernetes will implement some logic to put it back to 5, spinning up another pod, basically. So you have to tell Kubernetes within your operator code what action you wanted to take when that happens. And so it's kind of, you're kind of packaging up your code in a format that Kubernetes understands. And Kubernetes being your platform, you're optimally packaging your code for the platform it's going to run on. And lots of vendors or software companies have done this already. They've packaged up their code to install and manage and operate their applications on Kubernetes. So there's quite a few examples there. So it's usually the like tricky type applications that are not necessarily that easy to package up and monitor. Things like databases, where there's very specific operator knowledge that the owners or the sort of writers of this type of technology understand. So they're very well placed to be able to implement that logic into an operator. And this means that, especially for databases and things like that, where like if you have 3 instances of your database running and you want to add another one, there's usually some logic that has to be implemented to either make that database aware that there's a new instance in the cluster. So you might have to do steps like, I don't know, like flush the cache, add that instance to a cluster resource manager or something. Those type of steps that you would have to do if you were implementing databases kind of normally. Well, CockroachDB and all the other ones that you see on this page, they've implemented that logic into an operator so that it knows if another instance of the database is added. Kubernetes is going to spin out the logic through an operator to make sure that CockroachDB is functioning as desired. So I'd urge you to have a look at the operator hub.io. So if you're thinking about packaging up some application to run on Kubernetes, it might be done already for you. And there's lots of other sources as well. There's awesome operators in the wild. And then this actually is a great page. So the folk at KubeDex have made a consolidated list of all the operators out there. So all the ones in Operator Hub, all the ones in the awesome operators page I just showed you, and any other ones that they could find on GitHub. So if you were thinking, I think we might just go and have a look at that page. So there. Oh, can you not see that? Okay. Okay, it's not working. Okay. If you scroll down, they've actually grouped the operators in terms of function as well. So you see auto-scaling there. If you actually scroll through the page, you'll see security, you'll see databases. So they've grouped them nicely in the kind of function they're doing. So you can just grab that code and have a look at it and just see how they've written and coded their operators. And just to go back to the why, so why are people writing operators? And I've kind of just briefly mentioned it before, but we're basically extending Kubernetes to manage the resources your custom resources the same way that it manages its inbuilt resources. So you're trying to make a homogeneous system, and all the automation that Kubernetes is running is kind of native and in a familiar language, if you like, to Kubernetes. We can always keep our automation outside. We can always have some manual steps to happen when, for example, like we talked about databases before, if there's a new instance or a new instance of a database pod is running, do you have to do something manually to make sure that works? You can always do it manually or code it in a script outside of the cluster. But the goal of operators and kind of the beauty of them, if you like, is that you're bringing that automation into your Kubernetes platform so that everything is contained in there and you don't have different bits of automation, perhaps operated by different teams. You're kind of bringing it all in together so everybody's kind of speaking a common language. And then also with the operators, especially with all the examples that I've showed you on the previous pages, it's kind of making it now easier to deploy these complex applications. There's a lot of talk when I speak to customers is like, how easy is it to package up this piece of software for Kubernetes, and should I be running my database as a container? Codifying the operational knowledge into an operator just allows you the ability, as I said, to have everything running on the same platform. But you're now rethinking perhaps how that database application, or indeed your automation that you're trying to put into an operator, you're rethinking perhaps how that should work. And you're perhaps optimizing it for Kubernetes, because Kubernetes might do a lot of this stuff already for you. So when you start bringing that automation into Kubernetes, you might find that you don't need all the lines of code that you had before, because Kubernetes inherently as a platform might have a lot of that functionality built already. So you're all the time trying to streamline your systems. And if you're going to go all in on Kubernetes, you might as well try and bring in all your applications, as many as you can, to functionally run and be managed by Kubernetes, and not have different types of technology kind of dotted around the place, in an ideal world. Okay, so if you wanted to start thinking about how to write operators or delving a little bit more deeper into them, then there's just a few simple statements there. Most of them are written in Go. And the reason for that is because Kubernetes is written in Go. So again, when you're trying to run applications on a platform, you design them and write them in the language that's native to the platform. So it'll run more optimally. So most operators are written in Go. However, lots of operators are also written in Java and Ansible. So whichever you're comfortable with, you can make a start there. Red Hat, so we did a lot of Ansible stuff, so that was quite an easy thing for me to look at and understand a bit better than trying to understand Go straight away. So just be aware that it's not just Go that is the language for operators. And basically, when you run through some of these, when you're setting up an operator from scratch, there's various steps that a lot of the programs that help you to build them, there's a lot of steps that they go through there. And I've just summarized the steps there. And they're kind of obvious, but I just wanted to put them up here anyway. First of all, you want to create a new project. And I'll show you some of the tools in a minute. But the first step is to create the new project. Then obviously, you have to define the resource API. So you're basically defining your custom resource and your custom resource definitions. And then you have to tell Kubernetes in some sort of logic, what attributes do I need to watch? Which are the ones that you want are of interest to you? Because remember, I'm watching something, and if it changes, I want something to happen. So you tell Kubernetes which resources and which resource attributes you want to watch. And then, of course, you have to write the reconciling logic. If something goes from red to blue, what do you want Kubernetes to do, and how do you want it to fix it? Or what do you want it to run when that happens? So that's the logic. Again, that's kind of the main bit written in Go, but can be another language. And then, of course, you build the operator. So if we look at some of the toolings that will help build operators, because when you think about it, so there's controllers are out of the box in Kubernetes. And if you think about the kind of logic, it checks that something it checks the state of something and fixes it if it's not in a desired state and runs through that loop again. So if you have like 100 controllers, they probably all 80% kind of have that reconciliation kind of loop. So there's a lot of what we call kind of boilerplate code. So a lot of these tools kind of pre-write that code for you, and then you just need to insert your own specific operator logic into that boilerplate code. So it takes away a lot of the hard work and just kind of isolates the bits that you need to add. So it's definitely well worthwhile having a look at KubeBuilder, and there's also the operator framework as well. And the two links are shown there. Maybe if we have time at the end, I can come out to the web pages and show you. And then, so once you've had a look at those, there's also some good background reading material as well to kind of maybe frame a bit more like the context of operators and, again, maybe why they might be useful to you. And the first one is from CoreOS, and they were the guys who actually came up with the name in the first place, operators. So they were, they had this definition about codifying operational knowledge into Kubernetes. So operational knowledge of an application and coding that into Kubernetes. So it's well worthwhile to kind of see the history of operators, to have a look at that link. Then I've also put up the link for the awesome operators. Again, open source, kind of free resource for you to have a look at some operators that have been written already for two reasons. First of all, if you're thinking about writing an operator, it might be written already, right, for a particular application, like Kafka or some of the Aquasex stuff, or again, the CouchDB stuff I talked about earlier. To have a quick look and see if the thing you're thinking about writing as an operator, see if it's been written already. And the second reason to kind of look at these examples is kind of, again, to help you understand how to build these things. To see some pre-written running examples, for me anyway, always helps me kind of frame exactly what I need to do to build mine. And then the last one is a nice kind of comparison and a discussion of what controllers are versus operators. And that was written by my colleague, ex-Heptio colleague. So in summary, I just wanted to say what we've done already. So we've kind of defined what controllers are, and they're all the time trying to move the current state of what the world is to the desired state. Again, the kind of sole operation way of working that Kubernetes has. And operators are controllers for your custom resources. And they're codifying operational knowledge you might have of your application into a format that's understandable by Kubernetes and managed by Kubernetes. And as I showed you, lots of software vendors are now creating operators for you, and kind of with that, they're kind of giving you a nice pre-prepared package to install their software. But they're also kind of doing the hard work for you in kind of codifying the best practices for managing that piece of software. They're kind of doing it, that coding for you and building it for you. So again, always just check that what you're thinking of making into an operator hasn't been built already, or indeed something very similar to what you're looking to do. And it extends the functionality of Kubernetes. So you're making this platform that you're developing, as your new platform perhaps, and you're investing a lot of time into it. You're extending it to do more than just what it does out of the box. You want to extend it to do the specific edge kind of cases that you have, and bringing all your automation into the same sort of functionality that Kubernetes has out of the box, which is very, very, very powerful. Okay, that's it. Does anybody have any questions? I'll put the web page up in the meantime. So I just wanted to point, it's not even on, okay, hang on. Yeah, KubeBuilder is a really good tool for trying to, a resource for building that boilerplate code, so you can take what KubeBuilder has and go through the steps. And it kind of shows you on the screen kind of steps that it goes through to build the code. So that's an excellent resource. And I just wanted to point out one other resource. Top of the page, the TGIK. TGIK is, thank God it's Kubernetes, and it's a live YouTube feed run every Friday from, it started off with folk at Heptio, but there's lots of contributors who contribute to it. So it's a kind of an hour, hands-on. Joe Beda does it a lot. Chris Nova, and they spend an hour on Friday just literally taking something that's of interest in the open source community and just, line by line, just going through the code. So there's been 3 kind of episodes in and around KubeBuilder and controllers and operators. And that episode 40, the first one, it's really useful for going through like step by step. Let's go through KubeBuilder and let's go through step by step how we use that to build me an operator. And it's you know, as I say, it's hands-on. So it's like the person who does it is generally looking at that project for the first time as well. So you kind of get a feel that, you know, you're kind of in it together. We're going to look at this project today and we're going to figure out how it works. And then there's 2 others on Minecraft, building a controller for Minecraft. And then another one building a controller. So there was like number 7 first, then 40, then 83. But I'd encourage you to have a look at TGIK, not just for the KubeBuilder stuff, but there's 98 episodes now, so there's like pretty much everything to do with Kubernetes and the ecosystem. There's probably been an episode of that. So have a look at that. So if there's no more questions, well, any questions? I'm not sure I have a microphone, but.
What sort of restriction will the operator code be, restricted to? As in, it's running within the container, but it would have access to do anything?
Yes. So the question I think is the operator. Does it have any restrictions? Like, does it all have to be in cluster, or can you have stuff outside the cluster? Is that correct? So again, it's kind of. It depends. It depends what you want it to do, what kind of access that controller or the operator running in a pod might need to the outside, or whether you're prepared to grant that automatically, or whether you implement some sort of manual process. But because it's your code at the end of the day, it's your system that you're trying to get Kubernetes to manage, it's your application, then those kind of decisions are yours. Most of the stuff I've seen is implemented in cluster, but there's generally some sort of write out. So like I've seen one where every time like a team provisioned something in a namespace, then there was a write out to an internal, like internal but external to the cluster, CMDB, that kept a record of that. So they could kind of use that information to kind of understand who's doing what. Externally, like in their ServiceNow type external CMDB system that they had. So those kind of things, so you can get Kubernetes to watch, and then one of the things, the actions of a change in the thing it's watching would be to write something out to keep a track of it. Or indeed raise a ticket, like ServiceNow ticket. I've seen that done as well before. Some people still want to have that ticket-based system, and something happens automatically, then create a ticket in ServiceNow. Any more questions? Excellent. Oh. No, so the question was like KubeBuilder or operator framework. No, not really. I looked at operator framework first because it had the Ansible bits in. And then as my kind of Go knowledge got a bit better, I was kind of looking at the Go elements. And then sort of internally within my team, there was a lot more folk looking at KubeBuilder. So I just looked at that. But they're kind of two, like anything, there's never just one option, is there? So I'd worth having a look, especially if you're like really strong on Go, then KubeBuilder is all Go. Maybe if you're looking at another language, have a look at the operator framework. But there's no legions for me, either one. Any more questions? No? Okay. Thank you. Thanks.